am with you today. I am across the street, but I am with you. And we are going to put in the notebook, because I said so, you. Yes, you. See me? I'm pointing to you. Need to write this down in your notebook. This is the first thing I'll check for Chapter 7, labeled Ratios and Proportions. I'm going to go pretty quick through this, and you can pause it if needed, okay? All right, so I need to go over some vocab first. Pretty simple vocab. First vocabulary term being ratio, okay, which you learned way back in 6th grade, maybe 7th. So ratio, what the heck is it? It's just a comparison. You're comparing two quantities. So I'm going to put a comparison. Okay? And if I extend that idea, called the extended ratio, this one is a comparison also, okay, but of more than two quantities. Okay, this one's two quantities. An extended ratio is going to be more than two. If I go onward, some other things that are talked about in this section that you need to know before we actually start on the problems would be, okay, we've said ratio, we've said extended ratio. Now I can go into what's called a proportion. And a proportion, if you remember at all what that means, is when you have two ratios that are equivalent to each other. Then we can form a proportion. If not, you can't form it. And then if you actually form a proportion, let's say the proportion, all in variables here, is A over B equals C over D, then there are certain terms within a proportion. The first and last terms of a proportion, from the upper left to the lower right, are known as the extremes of the proportion. And then if I go to the middle terms of a proportion, those are known as the means. Okay, those are the means, these are the extremes. And in a proportion, the product of the means is equal to the product of the extremes. That sounds so cool. In a proportion, the product of the means is equivalent to the product of the extremes. And if you aren't mathematical, you would have no idea what that means. Okay, so now if we actually extend that idea one more time, not one more, I'm going to extend it 3 more times. There are 3 more properties you need to know with proportions. So we know, first and foremost, this is the most important thing ever, that the product of the means is equivalent to the product of the extremes. But then I can extend the idea, and if I have a proportion like, I don't know, let's just make one up. 1/2 is equal to, what should we say? I don't know, 3/9? No, that wouldn't be true. 3/6. If I am given a proportion, meaning it's true, this would be equivalent to writing, instead of writing 1/2 equals 3/6, I could write 2. This is what they want to see you do. These 2 values, I could look at it this way. I have the B and D value here, 2 and 6. I could write on the top instead. And then I could write in the AC value on the bottom. And this would be the same proportion. These are equivalent to each other. Okay? Because if you actually look at the means and the extremes, look at that. They're the same! Okay, let's go to another property. I start with the same thing. I'm going to erase this. I need more room. And will it let me? Yes. Sorry, I'm whipping through this. I don't want to spend too much time on it. What was the proportion I had? 1/2 equals 3/6. And that is going to be equivalent to, yes, we said we could flip it around, but let's look at it this way. Let's say, let's take these values that we're looking at and go 1 goes with 3 just like 2 goes with 6. I could write it that way also, and those would be equivalent. Because again, look at the means and the extremes. They're the same. Okay, one other feature. This is kind of a weird feature, so get ready. If I have 1/2 equals to 3/6, it is also equivalent to this ratio, this proportion. Okay, this is a weird one. 1 plus 2 over 2. And 3 plus 3. Whoops, not 3. Sorry. I got excited there. It's whatever number's on the denominator. So 3 plus 6. So let's see if this actually works. That's 3 over 2. Is that the same thing as 9 over 6? Yeah, man! Weird how that happens. Okay, so let's actually try some of these. So you're going to do right now on page 432, you're going to try out the got it problem number 1. Okay, you're going to pause the video, you're going to try it, and then you're going to play the video to see if you got it right. So I'm going to start on the problem. So pause the video, otherwise you're cheating. Okay, all right, so here I go. All right, pause the video. Did you pause it? Okay. So, starting on this problem, bonsai tree, 18 inches wide and stands 2 feet tall. Write the ratio of width to its height. So I have 18 inches to 2 feet tall. And I'm like, oh, I'm done. No, I'm not. Look at here. In order for the ratio to be simplified, these need to be the same unit. So they need to be both inches. So there would be 18 inches over 2 feet is equivalent to 24 inches. So now I have the same unit. So now I'll simplify the ratio. And 18 over 24 would simplify to, let's see, divide them both by 6. And I'm at 3/4. Cha-ching! Done. Got it? Okay. Let's go to another got it problem. Page 433. Got it number 2. Okay, try it. Pause the video. Try and figure it out. Okay, I'm starting, so hopefully you paused it. Hopefully you tried it. All right, it tells me the measures of 2 supplementary angles are in the ratio 1 to 4, and that the angles are supplementary. So in my mind, supplementary adds to 180. So could the angles be 1 degree and 4 degrees? No, because if I add those together, I'm at 5 degrees. But that's in the ratio 1 to 4. Yeah, it is. Well, let's find an equivalent ratio to 1 to 4. What if we double this? 2 to 8. Are we good then? 2 degrees, 8 degrees. Is that going to give me 180? Heck no. Okay, you see how this can take a long time if I just keep doubling and tripling and just doing guess and check. So I can make use of my algebra-ness to figure this out by saying I'm going to take 1, multiply it by some number, and add it to 4 multiplied by that same number. Because remember, first I doubled them, then I tripled them. And I want to see that I get 180 degrees. So then I would go ahead and solve. Divide by 5. And x is going to be, I don't know that one off the top of my head. That's 15 plus 30, so that would be 6. 36, so am I done? No. So I sub that in. So one angle is going to be 36 degrees, and then the other angle is going to be 36 times 4, which is 144. Okay? All right, you're not done. We're going to the got it number 3, page 433. Got it number 3. And this one, links, pause the video, try it. Don't cheat, people. And Murphy, stop singing. Maybe you're not. Maybe you have controlled yourself. Okay. The lengths and the sides of a triangle are in the extended ratio of 4 to 7 to 9. 4 to 7 to 9. Hopefully you paused the video and you tried this. The perimeter is 60 centimeters. What are the lengths of the sides? Okay, are the lengths going to be 4 centimeters, 7 centimeters, and 9 centimeters? Well, if I add those together, am I at 60? No. So they need to be in this ratio. So I need something equivalent to this extended ratio. So would I double each one of these and then be good? Probably not. What about tripling? What about quadrupling? What about I don't know what? So I'm going to use algebra. 4x plus 7x plus 9x and see when I get 60. So if I add these together, how many x's are there? 16. 20. Oh, that's nice. So if I divide by 20, my x value would be 3. Meaning that this is not a side length. I'd have 4 times 3, one side would be 12. 7 times 3, one side would be 21. And 9 times 3, one side would be 27. And that'll give me a perimeter of 60. And if you don't agree, or if you're unsure, add it up and see for yourself that it actually equals 60. Okay, you thought we were done? We're not. We still have 2 more got it problems, it looks like. So on page 434, got it number 4, try it. See if you cry on these ones. I do have Kleenex in the room if you need it. Okay, pause the video. We are starting now. 9 over 2 equals a over 14. You can solve this however you want to. I'm going to use the property of the means and the extremes. The extremes, the product, 14 times 9, is supposed to be equivalent to the product of the means. So 14 times 9, 63, 126 equals 2a, divide by 2, and my a value would be 63. Cha-ching, done. All right, moving on. We are at got it number 4, part B. Part B, let's see. Ooh, this one's a good one, finally. Equals 3 over m. I'm going to do the same idea. Product, 15 times m, equals, this is the trick right here, it's 3 times, not just m, but the quantity of m plus 1. I have to put it in parentheses since it's more than one term. And then I'm going to make use of the distributive property. Then I'm going to combine like terms. So I'm going to subtract 3m to both sides. And I'm at 12m equals 3. Divide by 12, and my m value is 3/12, which simplifies to 1/4, which could also be written as 0.25. That's a lovely one. Okay, now I only have 2.5 minutes left for this video, so got it number 5 on page 435. Try it out. See what you think. Pause the video. Okay, here's the original. I'm starting in part A. It says 6 over x would be equivalent to what? Well, all they did was flip this. So I'm going to flip that. I'm not going to flip out. And I'm at 7 over y. Okay, then I'm going to go to part B. Something over something equals y plus 7 over 7. I wonder what they did. They took the 7, added it to that. So I'm going to take the 6 and add it to that. So I have x plus 6 over 6. Cha-ching, done. Part B, bye. Okay, I have a minute and a half here. Part C. It is asking, explain why 6 minus x minus 6 equals 7 over y minus 7. Okay, why the heck is that the same thing as this? Well, I could prove it by looking at the means and extremes. The product of the means and the product of the extremes should be the same. In this one, it's 7x equals 6y. Is this one the same? Well, I have 6 times the quantity of y minus 7. In this one, I have 7 times the quantity of x minus 6. Simplify that. 6y minus 42 equals 7x minus 42. Get the 42's together. Add 42 to this side. So what happens? They cancel, and look at that. 7x equals 6y, which is the same thing. Weirdness. Okay, you're going to check Gunnison Math to see what problems you're going to practice your set of problems from 7.1. Good luck and get them done to turn in to me at the beginning of class on Thursday. Good luck, people.